Okay, fine. Firstly,
Hmm.
we are having the charge or
Charge.
electric charge,
Q.
which is indicated with either with Q or capital Q or E.
Ah.
Charge is the fundamental property which experiences the force of attraction or force of repulsion.
Hmm.
Okay. Charge is a
Ah.
property. Okay. It is not fundamental property, because in fundamental property, current is the fundamental property.
Ah. Okay.
Charge is the property which experiences the force of attraction or force of repulsion.
Repulsion.
Okay. Force of
Hmm.
repulsion.
Attraction or repulsion.
Hmm. Now, this charged particle will be of two types.
Okay.
This charged particle will be of two types.
Correct.
Number
Yeah.
one, it is positive charge,
Hmm.
and number
And
two,
negative
it is
charge.
negative charge.
Hmm.
Negative charge. And the magnitude of charge we can write as,
Ah.
if it is positive charge means I can write plus 1.6
Plus
into 10 power minus
10 to
19.
the power of minus 19.
If it is negative means we can write it as minus
Minus
1.6 into
1.6 into 10 to
10
the power of
power
minus
minus
19.
19 coulomb. Okay. So
Hmm.
SI unit of charge is coulomb, and
Yeah.
CGS unit will be stat coulomb.
Okay.
CGS
This is start Coulomb.
charge is stat coulomb.
Stat Coulomb.
Okay.
Yeah.
Fine.
Yes, sir.
Now suppose let us consider I am having a positive charged particle and I am having a negative charged particle. Okay. That means we can say these as unlike charges. Okay. Between the unlike charges, we'll have the force of attraction. That means both the particles will approach each other. Both the particles will
approach each other.
Attract each other. Okay. Similarly, we are having the force of repulsion. Okay. Let us
They will repel each
consider
other.
here I am having the positive charge
And positive.
and another positive charge. Here I can
Repel
say
each
it
other.
is unlike charges.
Yeah.
Okay. This one it is like charges.
Like charges.
Same charges. I can also consider the two particles as both negative particles. Right? That
Yes,
also
sir.
I can call them like charges only. So for like charges, we are having the force of repulsion. So that means the two particles will move away from each other. It can be called as force of repulsion. Okay. Force of attraction and then force of repulsion. Okay, fine. Now the charge we explained now. Okay. Now then we are having the properties of the charge. We are having the properties of charge. Okay. First property, it is that charge must be quantized. Okay. First property is
charge must be quantized.
Charge must be
Quantized.
That means that charge must be quantized means that suppose if I'm having only one charge particle, I can write it as, if I'm having only one particle is there, I can write the charge of the system is equal to E. That is nothing but 1.6 into 10 power minus 19 coulomb. If I'm having the more than one particle, suppose 3 are there, then the charge of the system will be sum of the charges
Q1
of all the 3
charges.
particles.
Yeah.
Okay, na? So if all
Mm.
the particles are having the equal charge,
Then in
Q1
3n.
equal to
So n
Q2
equal to
equal to Q3.
Q3.
That is equal to plus
3Q.
E. Then I can write 3.
Uh,
Need not necessarily all the times will have the charges will be the same.
mm.
Okay. Suppose let's
And
consider
then
an example. Let us consider example. Q1 equal to plus 5E.
mm.
Q2
Q2 equal
minus
to
80.
minus 8.
Q3 10E. Then I
Mm.
can find the total charge of the system as
7.
Q1 plus Q2 plus Q3.
Q2 plus Q3, which is equal to
Okay.
7.
Which we'll get as the total charge of the system. I'll get as 7E,
Yes, sir.
right?
Mm.
Like this. Not all the times every charged particle will have plus E. Sometimes we'll have minus E, and
Minus C.
magnitude also it will be different. Okay.
Understood, sir.
So if you
Understood,
are
sir.
having n number of particles,
Mm.
okay, if system is having
In number of particles.
n number of particles,
Then
n
total
number
charge
of
of system.
charged particles, then the total charge or charge of the system, I
System.
can write as Ne.
Yes, sir.
Here we
Like
are
అన్ని
considering that
same ఉంటే
the charges of
same
all the
charge
particles, n number of particles
is
is
same.
plus E.
Same.
Okay, fine. Okay.
So
So this is my first property. Charge must be quantized.
quantized.
Next, second property. Second property is charge must be conserved.
Charge must be conserved.
Charge must be conserved.
Conserved.
That means that number of positive charged particles must be equal to number of negative charged
Number.
particles.
Okay.
Such that
Mm.
total charge will be 0.
Okay.
Okay.
Mm.
We can write it as number of positive particles is equal
N
to
of
number
plus
of
is equal to n of minus
negative
c.
particles, such that the total charge will be equal to 0. Suppose if
Yeah.
I say that the total charge of an atom, of any atom, is 0, right? But if
Yes,
I say
sir.
the total charge of an ion, like Na plus or lithium 2 plus, like that, total charge is not 0,
No, sir. Because plus
right?
charge is more.
Because of unequal number of positive particle and negative particle.
Negative particles.
Okay.
Yes, sir.
Third property, it is that like charges repel each other. Like charges
Repel each other.
repel each other, whereas unlike
Like
charges,
attract.
unlike charges attract each other. Attract
Each other.
Okay.
Fine.
That's what we have seen earlier. Force of attraction and force of repulsion. Okay. Okay, fine. That is the properties of the charge. Okay. After these properties, we are having that. After these properties, we are having the Coulomb's law.
Coulomb's law.
Coulomb's law. It says that suppose if I am having the two charged particles, okay, having the
Yes,
charges
sir.
as Q1 and Q2.
Hmm.
And these are separated by distance.
R.
Suppose R.
Hmm.
These are separated by distance
Separated by
R.
the distance R.
Then Coulomb explained the force existing
The
between the two particles. Force existing between the two particles.
two particles.
Okay. Now there will be an
Hmm.
force will act on second particle
Hmm.
due to the first.
Yes, sir.
First, I'll call it an F12.
F.
That is force acting on Q2
Hmm.
due to Q1,
Hmm.
right? Okay.
Yes, sir.
According to Newton's third law, okay, for every action, there will be an equal and opposite reaction.
Opposite reaction. Yes, sir.
So there is a force which will act on
Act-
Q1 also.
Yes, sir. From Q2 to
That
Q1.
I can call as F21.
F21.
F21
F12 is
is
it
the
minus of
force
F12.
acting on
Q1
Q1
due
due
to
to
Q2.
Q2.
Yes, sir.
Okay. So according to
Yeah.
the Newton's third law, I can write it as F21 bar equal to minus F12 bar.
Yes, sir.
That is, with respect to
Vector.
magnitude, both are same.
Ah.
But with respect to direction, it is in opposite in direction.
Yes, sir.
Let us consider the magnitude of the forces as F.
Hmm.
Now Coulomb found the value of F.
Yeah.
He explained that the force acting between the two particles depends upon product of the two charges,
So that is and it is
right?
inversely proportional to
It is inversely
square of
proportional
distance.
to square of the distance
Square
between
of the
them.
distance between them.
So combinedly, we can say
F.
that F is
F directly
proportional to
proportional. Q1 Q2 by
Q1
R
Q2 by
square.
R square.
Yes, sir.
Okay.
So yes, sir.
Now, before this Coulomb's law, we are having inverse square law. In the inverse square law, it says that F is equal to Q1 Q2 by R square.
Hmm.
Later Coulomb came and explained the, okay, if this
Relation.
system, whatever the charged particles are there, that system
Hmm.
is placed in a medium,
Hmm.
then force will be different.
Okay.
Here Coulomb proposed the property of the medium. Property of the medium.
Hmm.
Okay. Okay.
Yes, sir.
Let me define the what is meant by medium. Okay. Fine.
Yeah.
Now, say for example, medium means the region or space. The region or
Or
space
space.
in which it is filled with either organic substance or inorganic substance. Either organic substance
Organic
or
substance or
inorganic
inorganic
substance.
substance.
Okay. Organic
Yes,
substance
sir.
or inorganic substance. Such that
Hmm.
either physical properties or chemical properties
Properties.
or electrical properties will changes. Will changes.
Hmm.
Suppose, say for example, let us consider I'm having 1 liter water. If I kept outside, then the temperature of water
Temper
will be approximately equal to temperature of the room
temperature
temperature,
surroundings. Yes, sir.
right?
Understood, sir.
Okay. The same thing, if The same water bottle containing water, if I kept in refrigerator, then
It will
temperature of
become
water
cooler.
decreased,
Yeah.
right now.
Uh,
Similarly, he explained that, okay,
okay.
we are having a medium in which here, if I keep the charged particle Q1 and Q2,
Q2.
having the separation distance as R,
R. Yeah.
then any one of its properties, like physical property, chemical property,
Chemical property.
electrical properties, any property will be changes.
Yeah.
Okay.
Yes, understood.
So, in order to explain which properties changes, Coulomb considered that in electricity, we are having a property called permittivity. Okay, na?
Yes, sir. Permittivity.
Permittivity. In magnetism, we are having the property called permeability.
Yeah.
In optics, we are having the refractive index,
Yes, sir.
right?
Yeah.
Okay, fine. So we are discussing electricity, na? So it's permittivity.
Duty.
Permittivity is indicated with epsilon. Okay, epsilon.
Yes, sir. Epsilon naught.
Fine. Now, see here. Whatever the, let us consider any property, any of the electrical property. Suppose let us consider resistivity, right?
Yeah.
Resistivity in a medium will be directly proportional to resistivity of the substance in air or vacuum. Can I say?
Yes, sir.
Similarly, here I am writing as permittivity in medium is directly proportional to permittivity in air or vacuum or free space. Right? So,
Yes, sir.
permittivity of a substance in air or vacuum or free space, we are indicating with epsilon naught.
Epsilon naught.
Okay. Is permittivity of a conductor. In air or vacuum or free space. Okay. In order to remove this proportionality, we are having a constant called K, where K can be called as dielectric constant. Dielectric constant. Even K also defines or correspondingly equal to the relative permittivity. Relative permittivity. That is nothing but epsilon R. That is epsilon medium by epsilon A. Right? Okay,
Yes, sir.
is it fine?
Yes, sir.
Epsilon naught for any substance, epsilon naught value will be constant. That is 8.85 times 10 power minus
10 to the
12.
power of minus 12.
Coulomb square by
Newton per meter square.
Newton meter
square.
So now we are having the Coulomb's law. According to Coulomb's law, we are having that F is proportional to Q1 Q2 by R square.
Yes, sir.
Okay, na? So in order to remove this proportionality, I need to have the value epsilon naught, because here the substance or particles are placed in air or vacuum, right?
Yes, sir.
Air or vacuum. So in order to make this this value I'll keep as x. Q1, Q2 by R square. This x must be in the form of epsilon naught. X must be in the form
in the form
of
of
epsilon naught.
epsilon naught.
Epsilon naught having this value. To make this one as integer value, I am keeping as multiply with 4 pi and take reciprocal.
Yeah.
1 by 4 pi epsilon naught.
4 pi naught. Q1, Q2 by
1 Q2 by
R square.
R square.
R square.
Okay. That is our Coulomb's law.
Yes, sir.
In air,
Yeah.
I can write F air equal to 1 by 4 pi
4
epsilon
pi
naught
epsilon naught
times
Q1, Q2
Q1
by
Q2
R square.
Similarly, F medium, whenever the two charged particles are placed in the medium, will have permittivity as epsilon.
Yes, sir.
So I can write charge, the value of charges will remain same and separation distance remains same. Here only variable parameter is permittivity will be changes.
Permittivity. Yes, sir.
Right? Since by definition, I know that epsilon medium equal to k times epsilon A.
Yes, sir.
Epsilon equal to k times epsilon naught.
Epsilon naught.
So instead of epsilon, I will substitute. That is F air equal to 1 by 4 pi epsilon naught times Q1 Q2 by R square.
R square.
Whereas F medium 1 by 4 pi epsilon into Q1 Q2 by R square. Since epsilon equal to k times epsilon naught, I'll substitute here.
Yeah. 1 by
F
k.
medium equal to 1 by 4 pi k epsilon naught times Q1 Q2 by R square.
Q2 by R square.
So 1 by k times 1 by 4 pi epsilon naught Q1 Q2 by R square. Right?
Yes, sir.
F medium equal to F A by K.
Yeah.
Okay, na? Okay, fine.
Yeah.
Now, after this, we are having the applications of Coulomb's law. Right?
Yes, sir. Application.
Okay, na?
Yes, sir.
Now it is applications of Coulomb's law. Suppose we are having a silk thread. To this, we are having the two charged balls.
Okay.
Okay, I'm having a two charged balls.
Two charged balls.
Okay. Now, these two balls are separated by a distance. Let us consider this distance is R. And these balls are having a charge Q and mass M. Both are having the same charge. Okay. This ball, here it is A and this is B. Suppose this is C. Okay, na? Fine.
Yes, sir.
Fine. Okay. Now, what I need to find here, what I should find, I need to find tension. And with respect to vertical, these balls makes an angle theta.
Yes, sir.
That value I need to find. With respect to vertical, the balls are making an angle theta.
Making angle theta.
Theta value I need to find.
Yeah. R.
Fine. So whenever the balls are connected, okay, there will be tension will act towards the point of contact or point of suspension, right?
Yeah.
Okay. Let us consider this point as D. Okay. So according to the vector addition, I can say AC bar equal to AD bar
AD bar
plus DC bar.
DC bar.
Okay, na?
Yes, sir.
So AD bar plus
Plus
DC
DC
bar.
bar. Yes, sir.
Okay.
Yeah.
AC bar. Fine. So I will find the DC value, DC and AD. AD in the triangle ADC, at D it is perpendicular, right?
Yeah.
So
D it is perpendicular.
AD, it is T sin theta.
Yeah.
Okay, na? Similarly
Yes,
in
sir.
this triangle also.
Yeah.
Okay. And
Yeah.
DC
DC.
will be
It will
T cos
be
theta.
T cos theta. Yes, sir.
Okay, na? T cos theta. Okay, fine. Now, here, since both the particles are having the same charge, na, we are having a force of repulsion. I consider the triangle ADC. This is my Coulombic force of repulsion. Okay. And here, this value it is T sin theta.
Yeah. And T cos
So,
theta. DC.
at equilibrium, I can write
FC is
T sin theta
sin theta
equal to
equal
FC
to FC. Yes, sir.
and T cos theta, that is DC. Vertically downwards, we are having mg.
MG. So MG
Right?
is equal to T cos theta.
So from both the triangles, we can write 2t cos theta. 2t cos theta equal to 2 mg, two particles.
2 mg. Yeah, yes, sir.
T cos theta equal to mg and T sin theta equal to Coulombic force.
Yeah, force.
Okay,
FC.
that is 1 by 4 pi epsilon naught
1 by 4 pi epsilon.
Q1 Q2. Here both Q1 and Q2
are same, so Q.
it is same.
Q square.
Separation distance R. Okay, na?
So R square.
By R square.
Yeah.
So T sin theta by T cos theta equal to Coulombic force by mg.
Yeah.
So tan theta equal to 1 by 4 pi epsilon naught
4 pi epsilon naught
Q square by
Q square by
mg
square.
R square.
Yeah.
Theta I can find from here.
Yes, sir.
Then I will substitute either in T cos theta or T sin theta. I can find tension.
Yeah. Yes, sir.
Okay, na?
Understood. Understood, sir.
Yeah, that is first application.
First up. Okay.
Now second application. The same, this pitch ball. Like this is there. We are having the force of repulsion. Right?
It's a.
Now it is placed in air. Now it is placed in air. Right now. Suppose if it is placed in a medium or it is immersed in a medium, suppose. like this. Okay, na? Like this, it is a medium. Whenever it is immersed, then what will happens? Upthrust is equal to loss in weight.
Yes, sir.
Can I say?
Yes, sir. After sugar, loss in
Upthrust
weight.
equal to loss
Loss
in
in weight.
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 So upthrust equal to weight of object
Weight.
in air minus
Minus weight of
weight of
object
object in liquid.
in liquid. Yes, sir.
So weight means mg.
Mm.
Weight means mg.
Mg.
This I can write it as rho s vg, where rho s is the density of
Under,
object in air or solid.
yeah.
This one it is rho l vg.
Density of object in liquid.
So rho s minus rho l
Rho into
times
Vg.
vg. So it is rho s minus rho l. Volume I can write as mass by density of solid. Can I write?
Yes, sir.
1 minus rho
Rho
L
L
by
by
rho S
rho S
times mg.
into Mg.
That is my upthrust. Okay, na?
Yes, sir.
Okay. Okay. So here, whatever the upthrust will act in the vertical upward direction.
Yes, sir.
Along in the vertical upward direction, we are having T cos theta.
Yeah.
So in this case, T cos theta is not exactly equal to mg. T cos theta plus buoyant force or upthrust is equal to mg.
Yeah.
Right now.
Yes, sir.
T cos theta plus Fb is equal to mg. Okay.
Yeah. Understood, sir.
Okay, fine. That is second application. Next. Suppose third application, I'm having the two particles. This is Q and this one it is minus 4Q. Okay. They are separated by distance. Suppose let us consider this separation distance as R. Okay. This separation distance is R.
R.
Okay. Let us consider this point as A and this point as B. Okay. We are having a third particle. Okay. We are having a third particle having a charge Q naught. Okay. Which is placed at the midpoint of AB. At the midpoint of AB. I need to find value of Q naught. Right?
Yes, sir.
Okay, na? Okay, fine. So let us consider this as C. Between A and B, between AB, you can see here, A it is having the plus Q and B is minus 4. So FAB, we are having the attractive force, right? So FAC and FCB must be repulsive. In order to keep the particles in equilibrium,
Understood, sir.
attractive force must be equal and opposite to repulsive force.
Yes, sir.
Okay, na? So
Hmm.
I can say that it is FAB is equal to minus FAC. That is minus FCB. Right?
Yeah.
Okay. FAB I can write as apply Coulomb's law. 1 by 4 pi epsilon naught minus 4q square by r square minus 1 by 4 pi epsilon naught. Either AC or CP you can consider. I'll consider AC. Q into Q naught by R by 2 whole square. Right? 1 by
Yeah.
4 pi epsilon naught, negative value cancel. So 4q square by R square equal to 4q Q naught by R square.
By R square.
4 by R square cancel. So
Yes,
Q
sir.
naught is equal to
Is
Q.
equal to Q.
Right? Now?
Understood, sir. Hmm.
That is like this. So
Yeah.
we need to find the magnitude of charge of the third charge, which is placed between the line joining the charges.
Yeah. Understood, sir.
Right?
Yeah.
Okay, na?
Hmm.
Next one it is, we are having the charges. Suppose this is plus Q and here it is minus 4Q.
Minus 4.
Minus 4Q.
4.
They are separated by a distance.
Hmm.
They are separated by a distance.
Distance A.
Okay. Okay. Distance. And the
Distance A.
third charge is placed. Okay. Suppose Q naught.
Okay.
Third charge is placed at a distance of A by 3
A by.
from Q.
Yeah.
What will be the magnitude of Q naught?
Hmm.
Okay. Right?
Hmm.
Same method. A, B,
B
and then C.
and C.
Between AB,
A
we are having force of attraction.
4 by
A square. Between AC, we are having
AC
the
we
force
have
of repulsion.
force of repulsion. 4 by epsilon naught into
Into
Q
minus
Q naught
into Q naught by
by
A by 3 whole square.
A by 3 whole square.
So upon solving, we'll get as 4Q by A square
A square is
equal
equal to Q
Q
naught
naught
by
into 9 by
into
A square.
ah
So Q naught equal to 4Q by 9.
by 9.
Right?
Yes, sir.
Okay, fine. That is fourth one. And last one it is, last application. If we are having the two charged particles, having the charge as 3 microcoulomb and 5 microcoulomb, they are separated by a distance 20 centimeter. Okay. We are having a force as F naught or Fa. If it is placed in a dielectric constant,
Dielectric
of 10,
constant.
then find F medium. Right? So F air I can write as 1 by 4 pi epsilon
1 by
naught
4 by epsilon naught.
Q1 Q2
Q2
by R square.
R square.
That
Yes,
is
sir.
F air equal to 9 into 10 power 9
10 9.
Q1, Q2 means 15 into 10 power minus 12,
15 in
right?
by
Okay.
20 into
Separation
10 to the power
distance 20 centimeter.
20 in 20 into 10 to the power minus 2.
Convert into meters.
Uh,
So 15
whole
nines
square.
are 135
1 yes sir.
into 10 power
135 into 10 to the power minus 3 by 400
10 power minus 2.
minus 2. Yes sir.
Okay. So F medium,
Nada.
since I know that F medium is equal to F air by K, right? F air 135 by 40.
Yes sir.
135 by
135 by
40.
40
K means 10.
by 10.
So 135 by 400
400.
Newton. Okay. Like this, we are having the applications of the Coulomb's law. Okay.
Yes sir. Understood.
Okay, na?
Yes sir. Understood sir.